Hey students, I wanted to go over 7.6 really quick. All we're doing is we're talking about the difference between linear functions, straight lines, and exponential functions, curved lines. So we're doing all this exponent stuff. Now what happens when you start putting them into equations and functions, all right? So I'm gonna go pretty fast here, so if you wanna copy these notes down really good like, you probably wanna push pause every once in a while. That wouldn't be a bad idea. So here we go, we're gonna fly through this. So basic straight lines and curved lines. Now their basic equations look like this. Okay, we've seen this before. This is slope-intercept form. We all know this. You start here, move by this. Here is what an exponential function looks like. There's a starting amount out in front of the beginning. Then you take that times this thing called the growth factor, which is just another number. But then you power that to an exponent. Okay, so this is the variable. This is how many times you're going to grow, just like how many times you would apply the slope. So this is where the variable goes. This is where your x values go. And then it's connected by multiplication. Now another thing I like to do is I actually like to put the growth factor in brackets, which you'll see here in a second. Okay, so this is just the basic formula and how they're built. Some more things about them. Again, slope-intercept form is repeated addition or subtraction. This is repeated multiplication or division, usually multiplication. Some bits and pieces here. Positive slope versus negative slope, and then exponential growth versus exponential decay. This should be kind of a no-brainer here really quick. If you have a positive slope, it's going to increase. If you have a negative slope, you're going to decrease. Okay, we kind of already know that. I'm going to slide this up here a little bit. There we go. Again, we know that. You would start at 15, 1 to the right, change in the height. Start at 100, 1 to the right, change in the height. Okay, so this one is negative, it'd go down, positive goes up. Now over here, if you want to grow, that growth factor needs to be bigger than 1. If you take something times 1, nothing happens. But if you take something times bigger than 1, it's going to grow. So here I start with 50, then I'm going to double it so many times. I'm going to double it, then double it again, then double it again. You'll see the table here in a sec. Here I've got 5,000 times 0.2 to the x power. If you want something to decay or get smaller with an exponent, whatever you make it grow by needs to be 0 point something. 1 does nothing, 0 completely erases it. So somewhere between 0 and 1 is where things are going to decay. So basically 0 point something. The basic look of their graphs, this one would start at 50 and then it would double, 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 and it was going to get out of control really fast. 5,000 times 0.2 is going to shrink really quick, and then it's going to kind of slow down. So this is kind of the basic look of their graphs. Exponential growth, exponential decay. All right, let's slide on up to what the tables look like. Now this is a lot, I agree. So you might want to copy all this down, push pause, and then you can go over it with me here in a sec. So now would be a good time to push pause, copy all of this, and then we'll go over it here right now. So 3x plus 15, what do? You start at 15, you add 3. We know this, we've done these tables before. Plus 3, plus 3, plus 3, it's linear. It's consistent, it's called a constant increase. So if you're going to use an official math term for it, you would say constant increase. Start at 100 and minus 5x. Start at 100, you minus 5, minus 5, minus 5, all the way down. That's called a constant decrease. By the way, this right here is something you probably want to look at a lot when you do the homework quiz. Okay, here we go. 50 times 2 to the x power. You start at 50, then you double, and then you double, and then you double, and you double. As you can see, it grows really, really quick. That's why the line curves so fast. This is called exponential increase. Right here, starting at 5,000, taking it times 0.2, it's going to basically divide by 5. This is actually 1/5 as a fraction, which is the same thing as dividing by 5. So look what happens. Divide by 5, and we get all the way down to 8. So it shrinks very, very quickly. It decays very, very quickly. Again, 0.2 is going to make it get smaller, all the way down to 8. So that's exponential decay. So this right here is basically the meat and potatoes of the lesson. We're comparing straight lines, linear equations, increasing, decreasing, to growths and decays. That's it, friends. That is 7.6. We'll see you later.